Alright, so we're on a part 2 of a series of solving videos, and now we're going to talk about solving log using properties, okay? So you've already learned how to condense and expand, so now we're going to learn how to condense and expand and solve the log after you do that, okay? So first we're going to review from the last video, and when you have two single logs, see, two single logs with the same base set equal to each other, we can cancel these logs out, and we can set the insides equal to each other. So it's going to be a equals 4a minus 9. And now it's just a linear equation. We get our a's to one side. I'll have negative 3a equals negative 9. Divide by negative 3. And x will equal 3. Now remember, you cannot take the log of a negative number, so just do a mental check. 3 makes that positive, and 3 makes that positive. So 3 is a solution, okay? All right, let's do another one. All right, so here, you've got two single logs set equal to each other, okay? Same basis, so we're going to cancel these logs out, and we're going to say negative 3m minus 1 is equal to negative 4m minus 6. Get your variables on one side, okay? So add the 4m, add the 4m. I get m minus 1 is equal to negative 6. Add the 1, and m equals negative 5. Now I definitely would check these negative numbers. So when I plug negative 5 into this log, I've got negative 3 times negative 5 minus 1. Negative 3 times negative 5. I do believe it's going to give us a positive. All right, so that one's good. And this one's good, because if you plug it in, it's got to equal the same thing, right? Let's see. Negative 4 times negative 5 minus 6. Yep, and that one's good too, okay? So negative 5 is an answer, okay? So your variable can be negative, but the inside of the log cannot be negative, okay? All right, so let's get to some using properties, okay? So when you want to condense, so it's all about condensing. We won't be expanding. We will only be condensing to solve, because your goal is to get it to be a single log on both sides or a single log on one side, okay? Because before you can solve a log problem, it has to be single logs. So if you look on the left-hand side, I have too many logs. Let's condense that. Before you can condense, you got to get rid of that number up front. So let's make it an exponent. So now I have log base 19 of 2 to the 5th. Minus log base 19 of x is equal to log base 19 of 8. Well, what's 2 to the 5th? We can simplify that. 2 to the 5th is 32. So I'm going to erase this and put 32 here. Now, when you're subtracting two logs, you divide. So now I have log base 19 of 32 divided by x is equal to log base 19 of 8. Now I'm back to what we've been doing over here, two single logs. So I can set their insides equal to each other, okay? And then, so this problem, it doesn't matter who's on the denominator. Whoever's on the denominator, you have to multiply it by, because you've got to get rid of the denominator before you can solve. So we're going to multiply by x on both sides, and I get 32 equals 8x. I'm going to divide by 8, and x equals 4. And that's my answer. Okay? So let's do some more. Let's see, right here. All right. So let's do number 21. All right, so it's a single log over here, so that's fine. Let's drop it down. Okay? Next one. This is not a single log. I need to get it a single log, okay? And in order to get it a single log, we have to do our condensing, okay? So before you can condense, you have to turn that number in front to an exponent. So now I have log base a of 3 squared plus log base a of 5. Well, what's 3 squared? 9. So we're going to replace it with 9. Now, I'm adding two logs, so when you add two logs, you're going to multiply the inside, and I will have 9 times 5. Well, what's 9 times 5? 45. So let's write 45. So I have two single logs equal to each other, so they cancel out. And I'm left with the inside. And the inside states x equals 45. Well, that was easy. No solving, right? So that is your answer. Okay? Let's do some more. All right. Let's do 22. Okay? 22. So, I need, anytime you have multiple logs on one side, you got to condense it. Okay? No matter if you're converting or canceling stuff out, you got to condense it. So the left-hand side is good. So it's going to be log base A of x is equal to, now, this number out front, I need to make it an exponent. And it's going to be log base A of 9 to the 3/2 plus log base A of 2. Well, 9 to the 3/2, I know that's weird, but type it in Desmos. 9 to the 3/2, that's going to give me 27. Okay, so I'm going to erase this and make this 27. I'm adding 2 logs, so that means I'm going to multiply their insides. I'm going to say 27 times 2. Well, I can say 27 times 2 in my calculator and get 54. Now I'm single logs, single ladies, cancel them out, and I've got x to equal 54. Okay? All right. Let's see here. We might, all right, let's do 24. All right, 24, they're single logs, right? But I told you, anytime there is something in front of log, you have to get rid of it. So we have to get rid of this 2/3 and make it an exponent. So now I have log of base b of x squared plus 7 equal to log base b of 64 to the 2/3. Well, you can type 64 to the 2/3. I don't know what's going on with my, okay, 64 to the 2/3. And I get it to be 16. Well, it already erased it for me. So 16. So now I've got single logs and nothing's in front of the log, so I can cancel them out. And I have x squared plus 7. Oh my gosh. Is equal to 16. I don't know what's going on. All right, I think I got it working now. All right, so we were here. We got this to equal 16 because we said 64 to the 2/3 power. So now I've got single ladies, so we cancel them out, and we're going to say x squared plus 7 is equal to 16. Solve for x. Subtract that 7. I get x squared is equal to 9. Square root it. Remember, when you square root, you have 2 answers. So x equals plus or minus 3. Okay? And when you plug those in, you're A-okay. All right? All right, let's see here. Let's do, let's do this guy. Well, let's get to him in a minute. Let's do 25 first. Okay? So 25. This is when, so I need to get it single ladies, right? So first we're going to get it singles. So I am subtracting 2 logs. There's nothing in front of them. So we're going to divide them. So I'm going to say log base x of 100 divided by 4 is equal to 2. Well, what's 100 divided by 4? 25. So I'm going to erase this and put 25. So now we're back to a previous video. Okay? I've got an x right here. So we've got to convert it. So x squared equals 25. X squared equals 25. Now, I know in your head you're like, oh, I know what that is. Okay, but sometimes you won't have a square. You'll have like x to the 9th power. And we've talked about this with solving. Whatever your exponent is, that's the radical you use to cancel it out. So, side note over here, if you had x cubed equals 8, you would take the cube root of both sides, and that would cancel out, and you would get 2. Okay, and the cube root is in Desmos, okay, so you can use it. But here I know that x equals plus or minus 5. Now, you can't have a negative base, okay, and so just like you can't take the log of a negative number, you can't have a negative base. So this is only going to be x equals positive 5, okay? All right, let's do another one like that. All right, so 26, same concept. There's nothing in front of logs, so we're good. We're adding the two logs, so we're going to multiply their insides. And I'm going to get log base x of 12 times 3 is equal to 2. Well, 12 times 3, that's 36. So I'm going to erase it and put 36. Okay? I've got to convert because x is over here. If x is with the log, you've got to convert. So it's going to be x squared equals 36. X squared equals 36. Well, you'll take the square root and can't have a negative base, so x just equals positive 6. Okay? All right. So we might, let's do a delta math by that one. Okay? All right, so here's one that you're going to see on delta math, okay? And it's kind of like what we just did, but we're going to talk about when you have rational exponents, okay? So it's single, but my x is over here with log, so we've got to convert. So I'm going to say x to the 5/3 power equals 243. So x to the 5/3 equals 243. To get rid of a rational exponent, you do the same thing as getting rid of a fraction. You multiply by the reciprocal. We're going to raise it to the reciprocal. So I'm going to raise both sides to the reciprocal power. Okay? It cancels out over here, but I'm going to raise 243 to the 3/5 power, and I get x to equal 27. Okay? And we can go back to delta math because I just snipped it. We can type in 27. Fingers crossed, I know what I'm doing. Ta-da! All right, let's do one more. All right, so what if you have a negative rational exponent? Let's do this one. So log is single, so I'm good. So let's convert. X to the negative 4/3 equals that. X to the negative 4/3 equals 1 over 256. You do the same thing. You're going to raise it to the reciprocal, but you're also going to raise it to the negative reciprocal. Okay, you keep the same sign. So I'm going to raise it to the negative 3/4. Raise it to the negative 3/4. It cancels out over here, so x becomes by itself. And I'm going to type in my calculator 1 or Desmos divided by 256. I'm going to raise it to the negative 3/4 power. And I get x to be 64. Thank God for calculators, because that would have really hurt to do in your head. So 64 is my answer. Let's type it in. 64. Go for it. All right, we're good. All right, so I want to go back to, there was one more I wanted to do. Okay. I want to do this guy over here. All right, so this guy has a lot of logs going on, like a lot. But don't worry, use your properties, okay? There's nothing in front of log, so we don't have to make an exponent. The left-hand side is being subtracted, so we are going to divide their insides. So we're going to say log of x divided by x plus 3 equals, they're also being subtracted on the right-hand side, so we're going to divide them, and we're going to say log of 1 divided by 10. Now they're both single, the logs cancel, and I have x over x plus 3 equals 1 over 10. Think back to math too, it's a proportion, okay? Proportions you cross multiply, okay? So we're going to cross multiply here. X times 10 is 10x. X plus 3 times 1 is just x plus 3. All right? That's why it's so important when we're solving methods, because they come back to you in math, okay? So we're going to subtract x. I get 9x equals 3. We're going to divide by 9. X equals 3/9, which is 1/3. Okay? All right. So I hope this video helps. You're going to have a delta math after this one, okay? Let me know if you need any more.